Hello everyone, we are Team 20 and our topic is diabetes mellitus detection and my teammates are Christopher Alvin Buana, Fatah Rosadi and myself Erva Maheshwar Reddy. Our project mainly focuses on addressing the global challenge of diabetes through a machine learning model which can detect diabetes and also classifies whether it is type 1 or type 2. Our main goal is to enable and to early diagnosis and to improve treatment outcomes for those who are affected. And the outline for our project is the introduction and also the related work and the architecture of our proposed model, proposed method and the data description and evaluation and the results and the conclusion. Introduction part for our project is in global now diabetes or challenge with a rapid increasing prevalence in the worldwide. In the diagnosis results in severe complications such as kidney failure and also the heart diseases. It is emphasizing the need for effective diagnostic tools. Unfortunately, existing solutions and also lack of comprehensive coverage for all diabetes types and also the demographics. Our project is aims to address all these challenges by developing a machine learning model to classify whether it is type 1 or type 2 diabetes. Also motivation of our project is the availability of high quality tabular data from various sources like Kaggle and the datasets, Pima Indian Diabetes Database and the Diabetes Health Indicator datasets from the year 2015 and also the year 2021. These datasets offer valuable insights into the diabetes related to our work. The main problem addressed in our project is the development of a machine learning model to assist individuals in identifying whether they have diabetes and also our model classifies the type of diabetes which is critical for determining appropriate treatment and also management. The key challenges in our project was to pre-process and merge the datasets, ensuring that consistency to achieve high model performance while potential the data. The primary goal of our project is to create an accurate and reliable diagnostic tool for the diabetes detection and the classification. And the machine learning model aims to classify whether the diabetes type is type 1 or type 2 and also will provide the actionable insights which will enable the personalized treatments strategies. This effort contributes to better management for care and also for the detecting diabetes in existing diagnostic solutions. The related works which we used for our project purpose is the already existing machine learning models for diabetes detection and for the classification, and also the main comparison is we use SOTA models for highlighting and improve the model accuracy and for the robustness purpose. The architecture of our proposed model in this we have involved two models. One is for detecting the diabetes and another is classifying whether it is type 1 or type 2. In these both models we will follow one consistent process to ensure the reliability and also the scalability. These two model approach the overall performance of the system, addressing that the unique requirements of each qualification task. And also the proposed method. The proposed method involves the use of three datasets which are merged to create a comprehensive and diverse training set, and also this integration improves the robustness of the model and also it increases the sample size. And also we are using multiple machine learning models for each task to enhance accuracy, and also in this process we will include careful feature selection and also optimize to achieve best results. And also data description for our this is, in this we will use three datasets to support its objectives, and also the three datasets are, one is from 2015 BRFSS for type 1 and one is 2021 BRFSS for type 2, and also the Pima Indian Database includes the future of classification whether it is type 1 or type 2. And the evaluation matrices of this one is based on the model and the F1 score, which are critical for assessing the classification performance, and also these experiments designed to compare whether to proposed models with existing sort of SOTA models. The experiment list in our project was it has two main components in this project. The first evaluate the performance of the models in detecting diabetes, while the second assess their ability to classify the type of diabetes. Both experiments benchmark the proposed models from SOTA. The experiment datasets in is, the first dataset is the 2015 BRFSS and it is for the type 1 diabetes, and also the 2021 BRFSS and it will detect the health indicators and also the risk factors for detecting type 1 and type 2 diabetes. And the dataset 3, that is Pima Indians Diabetes Dataset, it is having 9 unique features for classifying type 1 and type 2 diabetes. And also the experiment environment we conducted in Google Colab, and also we have used cloud based platform which provide the free computational resources, and also the hardware includes in it was the CPU, NVIDIA Tesla and also T4 GPU, and the RAM is around 12.72 GB RAM. And also Google Colab is easy of use to make an ideal environment for developing and testing machine learning models. Also the results of our project was the diabetes detection experiment. It indicates that CatBoost outperformed other models with an accuracy of 80.29% and the F1 score is 78.47%. The CatBoost ability to handle categorical features directly and its minimal pre-processing requirements, which contributes to its superior performance, to reduce the potential errors and also to enhance model reliability. And for the classification of type 1 and type 2 diabetes, LightGBM achieved at the highest performance, outperforming the SOTA models such as random forest and also the SVM. Its advanced gradient boosting technique and also the efficient handling of large datasets made it the most dataset. In conclusion, the proposed method successfully identifies whether a person has diabetes and classifies it into the type 1 or type 2 using advanced machine learning models like CatBoost and the LightGBM. By integrating multiple datasets, our project achieved SOTA performance with CatBoost and also excellence in diabetes detection and LightGBM leading in classification tasks. Our project demonstrates the potential for machine learning models to provide timely and accurate diabetes diagnosis for paving way for improving the treatment outcomes.
Okay, so hello everyone. So we're going to moving on to the demo section. So this is our collab code, and this is our code for the diabetes prediction and type 1 and type 2 prediction. And because of the time limitation, we will not perform all of the code. We will just perform the inference, and we will just explain our result in each slide. So first of all, we will just extract the code from our from the data. So first we just extract the codes, so the data from our data, and then unzip the zip file. We also import some of the models that we're going to need, and also the necessary libraries that we're going to need. First of all, for the diabetes prediction, we will use two datasets. These two datasets actually have the same feature. but they are just in different timelines. So we will just combine it into one large data frame. After that, we will check also if the data frames have any null values, and currently they don't. So we can move on to the dropping of the duplication, because if we combine two datasets in one, it will have some duplication. And after that, we will just perform an exponent data analysis where we check if the data has outliers or not. So by this, how do we do this? Is first we check the unique values of each column. And as we can see right here, after we check each of the columns, it seems that the maximum number of categories are 11 because of the income. The income are just types of categorical. So that is why we do a filtering of this one, where the numerical values we will check if they have any outliers. And after we check, they do have some outliers. So we will perform removing outlier using an IQR value removal. And so we will get this value. However, this value still has a very large imbalance. So that is why after this we will perform an imbalance balancing data. But before we do that, we will have to perform the feature extraction first, or feature selection first, by using feature importance method. And after we check this one, we can see that there are some columns that are not being used. So we will just filter it, and then we will get these columns. For the data imbalance, we will just perform an undersampling, so that the column will be the number of value will be the same. And after we do the undersampling, we will get the same values, which we can move to the preprocessing method. So for the preprocessing, we just use a min-max scalar, which is a normalization method. And after that, we move to the model and training validation, where we just use a series of model, and then we will try to compare. Again, because of the time limitation, we will just move on to the result. The result of the code is the training of the model, and also the result of each metric. And it will also give the best model that is in that case. So our current best model is CatBoost. We also plot this to make sure if the model is right. And we will go on to the type 1 and type 2 prediction. It's actually the same as the previous one, where we extract the data, and we actually use a different data for this one, because this one has some features that are not that exists in this data if we compare to the other one. And we did the same. We actually did the same preprocessing, but this one we actually just extract the outcome of the outcome of the diabetes, and then we perform some method to distinguish between type 1 and type 2. And after that, we will extract the important features that is used for our training data, and we will use a min-max scalar to normalize it, and then we will perform the same feature extraction again. Okay, so we're going to move on to the inference phase. So on the inference phase, we actually just need to run this code, and this code is just a series of a user input. So if you run this code, the code will ask you some questions, like do you have a cholesterol check? If you don't, you can click 0. And do you have any healthcare, like insurance or other types of any healthcare? You can say yes. Physical activities: do you do exercise? Do you eat veggies every day? Do you have a high BP? Do you eat fruits every day? How is your health based on the healthcare? How about your sex? Are you female or male? Do you have a high cholesterol? Are you a smoker? And I need to enter my age. So you can do, maybe for example we can enter 25. And how about the education? We can randomly pick this, and then enter BPI. You can check your BPI. For now, maybe let's just type maybe around 90. And how about the income? Currently we can set the income around this, and it will say that your condition is not normal, and this one it will define what type of diabetes you have. So you just have to input this again. So it will tell you which type of diabetes you have. So that's all of the inference section. Thank you so much.